Good morning, children. In the last class, we discussed about the think and discuss question answers, children. Today, we'll solve a problem which is over here. Example 5, children. A cannon of mass m1, that is equals to 12,000 kg, located on a smooth horizontal platform, fires a shell of mass m2 300 kg in horizontal direction with a velocity v2 is equals to 400 meter per second. Find the velocity of the cannon after it is shot. Okay, children, here you should know what do you mean by this cannon. What do you mean by cannon? Cannon means, normally in the old movies we see that when they burn the big masses of the big masses of bombs, normally they will be having like a bullock cart where they burn. That is called as a cannon, which is a very big huge bullock cart like, okay, where the hole will be there. Okay, that is called as a cannon. That means cannon mass is 12,000 kg. Here he has given that m1 is equals to 12,000 kg, children. m1 is equals to 12,000 kg. Located on a smooth horizontal platform, fires a shell of, here the mass of the bullet, that is a shell, that is 300 kg. 300 kg in a horizontal direction with a velocity v2 is also given. That means bullet is fired with a velocity of 400 meter per second. Okay, he is asking the velocity of the cannon. That means when the bullet is fired, okay, when the bullet is moving forward, the cannon moves backward. He is asking that with what speed the cannon moves backside. Okay, children, therefore now he is asking to find out the velocity of the cannon, that is v1 is equal to how much? Normally, according to the Newton's third law, okay, the rate of change of momentum, okay, that means the rate of change of momentum is equals to 0, children. That is the rate of change of momentum is equals to 0. Okay, therefore here normally we use the formula, that is m1 v1 plus m2 v2 is equals to 0. That means the net momentum is equals to 0. Why? Because with the equal force, okay, the cannon is moving as well as the bullet is moving, children. Okay, now here the final momentum of the system, okay, that means here the initial momentum of the system is 0. Initial momentum of the system is 0 and the final momentum is m1 v1 plus m2 v2 is equals to 0, children. Therefore, substituting this value, okay, substituting these values, children, okay, here what is the m1 is equals to 12,000 kg, 12,000 into v1, how much? v1 we don't know, plus m2 is equal to 300 into v2 is equals to 400, children. Therefore here 12,000 v1 plus 3 4s are 12 1,20,000, children. Okay, that is 12,000 v1 is equals to minus 1,20,000. Okay, therefore v1 is equals to minus 1,20,000 by 12,000. 0 0 0 0 0 0 12 ones are 12 tens. Okay, therefore v1 is equals to 10 meter per second. Okay, it is 10 meter per second, children. Here the value of minus v1 is equals to minus 10 meter per second. What did this minus indicate, children? Minus indicates that it is moving with the same velocity in the other direction, in the opposite direction, children. Okay, here the negative sign indicates that the cannon moves in the direction opposite to the motion of the bullet. Okay, children, therefore here the value is minus 10 meter per second, children. Here it is minus 10 meter per second is the value, children. Okay, children, have you understood? Yes. Okay, here we are using the formula, that is m1 v1 plus m2 v2 is equal to 0. Therefore, by substituting all the values, we get v1 is equals to minus 10 meter per second. Okay, children. And here next, here we had given the keywords, children. Keywords plays very important role. Okay, laws of motion. Here we are having of 3 laws of motion, that is Newton's first law, Newton's second law, as well as Newton's third law, children. Okay, what is Newton's first law? Newton's first law says that any body which is in the state of rest or state of motion continues to be in the same state until some external force acts upon it. And here Newton's first law is also called as the law of inertia, whereas law of inertia is of 3 types: inertia of rest, inertia of motion, inertia of direction, children. Okay, inertia of rest, that the resistance of a body to change its state of rest from to the motion is called as the inertia of rest. The resistance of a body to, in order to change its state of rest, state of motion, okay, to the rest is called as the inertia of motion. And here inertia of direction means, okay, the resistance to change its state of direction from one direction to the other direction is called as the inertia of the direction, children. Next we are having of Newton's second law. Newton's second law says that it explains about the definition of a force, that is F is equals to ma, children. Okay, next Newton's third law. Newton's third law says that for every action there is equal and opposite reaction, children. Okay, right. Next we are having of inertia. Inertia is the resistance of a body to change its state from one form to the another form is called as inertia. Here mass he is asking. The amount of matter contained in a body is called as the mass. And here linear momentum. Okay, linear momentum is nothing but, okay, we define the linear momentum as the product of the mass and velocity. The product of mass and velocity is called as the momentum. And here conservation of momentum, children. Law of conservation of momentum. Law of conservation of momentum says that, okay, the momentum of a body before the reaction, is equals to the momentum of a body after the reaction, children. Okay, the momentum of a body before the reaction is equal to the momentum of a body after the reaction. Okay, children. Next we are having of impulse. Normally impulse is denoted by the letter I. I is equal to F net into time, that is force into time. The product of the force and time is called as the impulse, children. Okay, and here impulse is divided into 2 types, children, that is impulse force and impulsive force. Okay, children. Here impulse force and as well as the impulsive force, children. Okay, what do you mean by this impulse force? Impulse force is that the large force, okay, or the small force acting for a long period of time. The small force acting for a long period of time is called as impulse force, children. Normally impulse force, example of impulse force is that, okay, the fielder catches the ball by moving his hands back in order to reduce the pain. The person who is jumping from a building, when he jump into the sand, he won't get hurt. Why? Because as it takes a long period of time in order to come to rest, whereas the person who is jumping on the concrete floor, he gets hurt. Okay, that's all are the example for the impulse force, children. Next we are having of impulsive force. Impulsive force is that, okay, the large force acting for a short period of time. Large force acting for a short period of time is called as a impulsive force, children. Okay, that means here normally when a boxer, if he hits the any person, he won't get hurt. Why? Because he will be acting his force only for a short period of time. Normally when we beat the wall or when we beat any object within a fraction of seconds, normally a karate fighter, he breaks the bricks with his hand. Okay, but even though he won't get any hurt. Why? Because here it is because as he won't get hurt because as he is applies the force only for a short interval of time, very few seconds, children. Okay, this is about the impulsive force, children. Impulsive force. Okay, children. Therefore here we are having all the keywords, children. we discussed about all the keywords, that is laws of motion, inertia, mass, linear momentum, conservation of momentum, impulse, impulsive force, children. Okay, children. Okay, right. Okay, by this we completed, children. Remaining we will be learning in the next class. Thank you. Have a nice day, children.